Chemical Kinetics Lecture Part 5 Mechanism of Reactions. What is mechanism of reaction? Mechanism of reactions of any chemical reaction is a total procedure from the beginning to end the formation of product. When we look into the balancing of equations or we do the experiment, we know that what are the reactants, what products are forming, but this is not all about. Intermediary time or between this, there are some intermediary action. There are some transitional even molecules form. There are so many reactions that conduct in presence of catalyst. So those everything A to G we can learn where this section called reaction mechanism. So the series of individual steps that add up to the overall observed reaction is called the reaction mechanism. Elementary process. In the reaction mechanism, there may be several steps of chemical reactions. As I said, the intermediary steps, that is transitionary. We can't say those type of molecule as a reagent or product, but also those type of molecules form for certain time interval, finally run the reaction to product. So each and individual step of total reaction mechanism is called elementary process. An elementary process is a reaction involving collisions between two molecules, and individual elementary step we will say that follow the rate law, and we can consider the stoichiometric equation only for the elementary step, that means single step of total chemical reaction. We can write the exponent by observing the stoichiometry coefficient, but this acceptable only for the elementary process. So let's now see some example. So the overall progress of a chemical reaction can be represented at the molecular level by a series of, as I said, the series of simple elementary steps or procedure. So here we can see the overall reaction. The 2 mole nitric oxide react with 1 mole oxygen to produce nitrogen peroxide. But this is overall reaction with the coefficient. But if we look into the overall mechanism, then we need to look into down. We can see here the 2 steps reaction. So each step is called the elementary step or process. As I said in the beginning, that we see the overall reaction, we can calculate the overall reaction rate, we can have the coefficient by balancing of reaction, but we never know that what is going on in the total procedure between the breaking of the old bond, formation of the new bond, when the molecules do collision, when their orientation is not going properly, or because of their orientation some transitional molecules form. So those we can see here when we study and propose the reaction mechanism. If we see in these 2 steps, what we can see that in the first step 2 mole nitric oxide produce the N2O2. This N2O2 react with oxygen and produce nitrogen peroxide. Okay, we have already, sorry, nitrogen peroxide. Now if we look into the reaction, overall reaction, this N2O2 is the intermediary. This is not the reactant, even this is not the product. So when we give up or nullify this intermediary, then we find the overall reaction 2 mole nitric oxide plus 1 mole oxygen that produce 2 mole nitrogen peroxide. So here every single step of this reaction mechanism is called the elementary step. And if we see here, we didn't see this in the beginning of the reaction, that means as a reactants. We even did not see in the product. So these are the transitionary and it temporary, and it happens during the events of total chemical reaction from the beginning to end. So it produces and then it goes up, used up. I already explained this issue. So you can see intermediates are those species that appear in a reaction mechanism but not in the overall reaction. So in a reaction mechanism means the total procedure of reaction events, and we cannot see in the overall reaction. That means we also cannot see in the overall balanced reaction. Since we tells in the beginning that elementary step contribute the direct collision between two molecules, so we can also little learn about the elementary process and molecularity. What is the molecularity? So as we already learned, the elementary step or process is any process that occurs in a single step, and molecularity is the number of molecules present in the elementary step. It can be single, it can be double, it can be more than 2. So when the one molecule in the elementary step, or we can say just one reactant, that means this is unimolecular. When two molecules in the elementary step of reaction mechanism, we will say or we will say bimolecular. That means there are two reactants participating in the reaction. When we will say the three molecules in the elementary steps or reactants, we will say this is molecular, but this is not so common. Now let's see the rate loss and rate determining space. So if we look back into this, single step reaction, we learned that the single step, that means elementary step, follow the rate law, and we can also use the coefficient of balanced reaction to write the exponent of the rate law. So that means we have the relation between the rate law and the rate determining step if we consider the elementary step. So the in the possible reaction mechanisms, we can get the sum of the elementary step must give the overall balanced. We know that the rate determining step should predict the same rate law that is determined experimentally. So before going to learn how we can write the rate and how we can find the rate determining steps, we need to make sure that rate determining step, by rate determining step we can predict the rate law, but still we cannot prove this is as a final. We have to prove the same suggested rate law by doing the experiment. And rate determining steps is the slowest step in the reaction mechanism. That means we just saw that there is a multiple step involves in the reaction mechanism, though we don't see in the balanced equation. We just see the overall reaction in the balanced, but the intermediary species or some other catalyst, whatever the third party was involved in between the event of chemical reaction, we don't see. So there can be two or multiple steps, elementary steps. So one single step can be slow, one single step can be faster. Now the question, the which step is slow is called the rate determining step, because those steps represent the rate law that similar to the overall rate of the reaction. Let's see the example. Before going to the look into here, before going to those part, you can see here unimolecular one. As we said that in case of elementary step, each single step we can consider the rate law, and where the concentration, where reactant rate is depend on the reactant concentration and the exponent value is the same as the coefficient value. But please do not confuse, this is only for the single step, that means single elementary step, not for the overall reaction. For overall reaction we need to find the exponent value by doing the experiment. So bimolecular AA product, see 1 2 molecule 2 2 molecule 1 plus 1 2 3 molecule 3 2A 1B 2 plus 1 3, like that. As I just said, that process occurs in one single step, the stoichiometry can be used. That means coefficient can be used. But always remember that this is only for elementary step, single elementary step. And if you look into your book, they also mention this, because sometimes a student get confused here. Now see here, sorry. This is another overall reaction, nitrogen peroxide plus carbon monoxide to form the nitric oxide and carbon dioxide. And the experimental rate law of this reaction with exponent with order is K concentration of NO2, and this is 2. Carbon dioxide is necessary for the reaction to occur, but the rate of the reaction does not depend on its concentration. So that's why overall we don't see carbon dioxide in the overall reaction mechanism. Now the proposed mechanism is here like that. 2 molecules of nitrogen peroxide start 2 mole react and produce the NO3 plus NO, and this is the slow step. Step 2, NO3 react with carbon dioxide and produce NO2 and carbon dioxide. Now, sorry, I want to little more write red color like the previous one to make it sure here. So if we look into the step 1, 2 reactants, so this is bimolecular. Now finally this is the intermediary, this also go here. So finally what we have, sorry, this is not the suffix, just to make sure, carbon dioxide. So already mentioned that why, but here, but if we write the law, so if we see, look into now the rate, and this is found the experimental. However, if we look into the step 1, we can see this is the two reactants, that means bimolecular, and also we can see here the two molecules, though we are not writing here the carbon monoxide. So this is how we can find out. So from this, and I want to mention here that which one slow, which one fast you will find. You need to look into the overall reaction rate and pattern, and you need to see the which steps have the that follow the rate law of the overall reaction. So if we look into here, it follow, and that's why. And also you have to see the slowest step is the rate determining step, that means it represents the rate law, and also the slowest step also represent the product formation. So if you look into here, is also the product, and NO3 cannot be either reactant or product, and the intermediary, unstable or temporary species also doesn't come within the rate. So this is how this step is the slowest step. Let's see, let's do one more example. Because I want to show you that if the reaction is carried in the presence of catalyst, how you can find also from the mechanism that which one is catalyst. You already learn already that how to find out which one is intermediate. So for this, let's write this very straightforward reaction, the decomposition of hydrogen peroxide. But let's write the mechanism here. Then we will write the overall rate. So this is iodide. And the first step, it forms water plus ion. Then this IO again react with hydrogen peroxide and form water plus oxygen plus iodide. This one. This is actually iodide. So now if we look into the reaction, what we are getting, let's take the color red. Okay, so it seems we can nullify here, we can nullify here, and then what we have overall reaction, 1 mole hydrogen peroxide plus another 1 mole. And then we will find the, let's write together, 2 mole water plus oxygen. So what are the information we can find from here? The first information we can find from here that this is the intermediary step that form that are not reactants, that are even not product, and that form during the event of the reaction as a temporary. Next we find another species that we use in the beginning of the reaction with the reagent. But reactants. Remember, reactants always participate in the chemical reaction to form product. But here, whatever the product we have, there is no product related to iodide. So that means this is actually catalyst. As we all know that we use catalyst to speed up the reaction. Catalyst never used up like reactants. So, when you will do the mechanism and this type of overall reaction, you can find out that this is the catalyst, and you also find out the intermediate space. Now, this is the slow step and the rate determining step. Why? Because if we look into the overall reaction, the bimolecular, and here is also bimolecular, and if we look into here, so we find the product. So with respect to here, what is our then rate here? Then here the rate, if we consider the rate law of this individual step, so we can write that this is the, yeah, we can follow about the overall reaction coefficient, and also we can write the rate from here. So that means if we look into the chemical reaction and do the mechanism, we can learn so many information, and once you got this, next you can do by yourself lots of practice problems. So that's actually the reaction mechanism. Whatever we find at the balanced equation, that's the overall, but the fact is that we can guesses from the reaction mechanism, but eventually we have to find match by using the experimental procedure. And in case of elementary step, we only can use the coefficient of balancing of equation to write the exponent. As I said here, here we go. One more time I want to take you. Sorry. Here. So concentration of A. Here is a 2, so 2. Here is a 2, 2. So this is how. Like if I, like just we example we did here, keep it. So if we want to write here, we can follow the same formula. That how many here? 2. You can write. But whatever the rate law we find in the slowest step or rate determining step, it should be same as the overall. But here we also see the same. 2 molecules of hydrogen peroxide. So I hope you got it. So that's all for the reaction mechanism, and we have the last catalyst, that will be the lecture 6 and end of the chemical kinetics. I will also try to make one practice review video, that means whatever the rate law, integrated rate law, half-life, about the kinetics, or so many equations we have learned here, and we also see lots of practice problem, but if I get time I will try to make couple of math problem or even the multiple choice question that can be helpful for the review of the total chapter. So look into that. yeah, I'm looking forward to this.